Lekazir anon bermai Lekazir anon bermai Lekazir anon bermai kan triat ngai lo le zir ngai lo te po kan hu lo le kan cho ngai lo te po izir zelang maso turin izir zelang maso turin Lekazir anon bermai Lekazir anon bermai Lekazir anon bermai.
Today we are going to study about some physicists and their works and forces in nature of physical laws. This topic are left in the first class. In the first class we learn about the physics, isn't it? And physics, different branches of physics and many more. Class musa khani nge musat kan zirto kami zomna khani. It is a continuation of the first class, okay? So this is under physical world. So some physicists and their works, physics scientists mela rang tele an na thote claim zong kan lo en don ani. So I think you can see some physicists are accumulation enge amu chuakha principle of buoyancy and principle of lever. Its country of origin Greece, Torricelli Italy, barometer, Galileo Galilei Italy, law of inertia. Tichuan hai Isaac Newton te United Kingdom, laws of motion, law of gravitation. Yung kang physicist tam takiko velan lo chuak to chuan discovery tapon neya inge physicist sinan discover ti teka knowledge tan fiat version shim turani mo knowledge in lo chin chiang WK Ronjan inge muchua anti chuan objective types multiple choice question local ta say X-rays were discovered by option A Isaac Newton, B Michael Faraday, C James Clerk Maxwell, D WK Ronjan. Digna chu answer to D ani ti nani chu tiang chun question kha local thaya hemi ba ka need JE ta po chu tiang chuan a local thei ni chu wang chun hemi gan tarlan na chan chu physicists and their work the country of origin thei knowledge ta treat ve ngai we shall not go in detail hey detail kal eme mangai lo ka kan treat ve ro angai ti nani maya hey la tam maya tianga ta po hian so neutron was discovered by Chadwick ite theory of nuclear forces were discovered by Hideki Ikowa, Japanese mo. Kan amucho katiang kan. You have to remember, okay, you have to remember and learn by heart the common one, okay. Scientists zong ma na traga tu tlenga physics zong Nobel Prize dong to zong chu in chin chia thailawang. But anyhow you have to remember some of these scientists, okay. Now next topic will be forces in nature, okay. Forces in nature, these are the four kinds of forces operating within nature. He to kovela universe he force pali hi poi mo tak hi anno mekani chu natural force kan ti kha kan siam ni loin mo mi va nek chop ka chu mani siam chop ani chu mo ka ting force ni lo kha. Number one is gravitational force. Number two is the weak force. Weak force kan ti hi nuclear force thawnia weak nuclear force and tia. And the third one is electromagnetic force. And the fourth one is the nuclear strong force and the nuclear force more. Number one, two country gravitational force. It is the force of attraction between two objects due to their masses and is governed by Newton's law of gravitation. Kanti class 10 class 9 apo kan zirto kha. Kha gravitational force kan bel lei hip na hei mo kan siam po nilo khwanu siam it's God made. Ya khania. He gravitational force kan ti khania. Formula is F equal G m1 m2 divided by r square ani. Hey, 1 by r square. Atia 1 by r square. The power 2 ani hin at alet po ni lawa. So ithiam har power 2 himo. Antinan 4 square ni chuan alet ni titaila 4 let ni chu pariat khani maya masa anilo ni 4 to the power 2 ni chuan 4 4s are 16 ani dai alet som paruk dai ni chu. So if we increase the distance between the two bodies by one time, if it is 4 meter, alet riatin force po atlaniam tina anilawa alet som paruk tain atlaniam don tina ni chu kan thretiam em chu wangan power ti hi alet tina ni lo ni mizo tong hian da dan hi la om chi alwa so ya har khop me power kan ti hi 10 to the power 30 kan ti chun alet som thu mani mi alwa 10 to the power 5 kan ti de khan alet nga ni lo ni chu kan thred on ania. So here are the properties of gravitational force. It obeys the inverse square law kan ti ka tunami ka inverse square law 1 by r square ti hi inverse square law chunia. And it also always attractive in nature. Gravitational force rang chu planet rang te ni le tha te hi anin hi vek tu ma anin repel lo ni. Hey, a like charge repel and unlike charge attract each other kan tiang chi kha in ang lo in hi pa charge chu ai nang ten repel kha ani velo mo negative le positive planet om velo ni chu negative planet positive planet om velo they are always attractive and in he vec each one. And also it is a long range force lat takatang in hip thai. Number 4, the graviton is the field particle of gravitational force. Gravitational force siam tu kan mu thai lo chu ahminga graviton an ti ni chu. It is the weakest force operating in nature makin tiam nature force song song chan at saklo per ani nga tinge khovelin chata kamin hip thai si chak takamin hip si kan ti chuan amma salen em wangani. So and if we look the equation F equal G m1 m2 m ki alen m mangai ni chu m2 ke mani machine ki tezok ni taila m1 tal ki chu alen m mangai planet rang ten lien m chu function a force kha we can feel the force of attraction can feel thei chu lung te le khabu te chu anin hip ton the ke mani machine po gravitational law mang khan kan hip vek ti chuan thria ma se tu ma mo nula le tlang valin du de wanin pan ten ingot lo chuan kanin hip chut lem lo ni mo teng khan kanin hip ton nei kan feel thailo achan chu weakest force ni. It is a central force and the chuan central force chu khoi tangin en hip kan ti chuan alai takatang ve in anin hip ton to enhance conservative force anti bokani. So we shall not go much in detail, okay? Tiang kal selang a weak force kati chun weak nuclear force antini. We know that there are elementary particles, okay? Elementary particles are like electrons te leptons te intra to ngam leptons te muons te intra to em electrons to intra larbi wang proton te po in siang. But you may not know about what is leptons. Muons, neutrinos and their antiparticles too. Nucleus chunga te mo hadi atom chunga hen kan mu thelo electron ba ka proton ba ka tam ta kano mani chu tiang how interaction chu weak force anti chunia mase gravitational force I chon achak de. The weak force has the following properties. Number 1, weak forces are short range force anin naite te in hip achan chu hladewa da in hip haklo atom chunga oman ni wangin. And the weak force is about 10 to the power 25 times a lit sum ni panga ni mielo 10 to the power 25 ti chumo mak engtiang kluk le ding on mun ni le mun ni clear mun noi khatin pun tir ta la chuting ba chu kluk le ding on into kluk le ding on into noi khat atamania 10 to the power mun a lit sum ni panga ti na ni lo ni. So you have to know that power means, okay? In a weak interaction, neutrinos act as a field particle. The gravitational force at one, field particle two, graviton, okay? Whereas in weak force, the field particles is neutrino, okay? You have to know that. Next is the electromagnetic force. Omletani electromagnetic force to sei zaw ngai vak long electric le magnet in shre mem electric le magnet in tharu ya nei kha I engwa ngai kan ti chun electric field le magnetic field can't force an ya to electromagnetic force ti tamai taila toy zong in chu mi tin charge ho te hi charge ho an mai hian rest mo rest electron po hian charge an ya proton pon charge an ya mai hian force an nei charge nei reng force an nei so the force between two static at rest electric charges governed by Coulomb's law om ve thuni so this F equal to 1 by 4 pi epsilon naught q1 q2 divided by r square ani tani chumo r square ania ka gravitational law len kana formula hin an na deu anei ni chu 1 by 4 pi epsilon naught hi constant ang khaloni ta se m1 m2 kan tia ya q1 q2 divided by r square hey Coulomb's law ti chu nia electromagnetic force electric le magnetic thrui timaila in mizo in short you may be able to understand so these are the properties of electromagnetic force has the following properties it obeys the inverse square law it may be attractive or repulsive in nature it is also a long range force and the photon so field particles of photon anti photon you may heard about it it is also 10 to the power 36 times stronger than the gravitational force and turu mi 36 times it is also central as well as conservative force gravitational force then kan in central force and next is the nuclear force the force operating in the nucleus are called nuclear or strong force and the nucleus atom ni mai loin inside the atom you may know that there is a nucleus omanity kain shia so inside the nucleus there are some particles like baryons and the nucleons to proton le electron khang tiang kha nuclear force chung nucleus chung khang nucleus chung interaction ho kha anchak mema binding energy chaklu tuk tak mai combine tlat me chu enge mo wangin ti phel rang thaya chu ba kha natural pathian in a siam and then radium to minor decay mo ake chereng baka it will release energy in sata kan release thinani chu baka jon machine in hey nuclear power ta kan te machine in kan siam chok ve theta so a human being can also create a large amount of energy from this nuclear force okay nuclear force are the interaction between nucleons inside the nucleus chungani mo so these are the following properties it varies inversely with some higher power of distance r square chuni value 1 by r square ni value 1 by r cube 1 by r to the power 5 higher power of distance ni value it is basically an attractive force ya mo it is a short range force and is operative only over the size of the nucleus chunga attraction interaction so field particle value the pi meson is its field particle okay it is the strongest force operating in nature it is about 10 to 38 times stronger than gravitational force and 100 times stronger than electromagnetic force it is a non-central force light takatang in hi velem lo amaro chu hi partially ani 10 khatero light takatang in hi nucleus chung in hi light takatang anom ve tho ne chu katiang kha chuan elahian ka soi mai pakhat omen ga ria electromagnetic force hian nichinang khan gravitational force to it is only attractive kan the electromagnetic force to number 2 can it may be attractive and in hip thaya or repulsive plus in a positive kan sia ka chun and repel or negative will repel isn't it but whereas plus and minus negative charge and positive charge will attract each other kaka electromagnetic force chona thayani but not in gravitational force okay so next will be nature of physical laws and this will be the last means we have 3 points so what is nature of physical law means nature of physical laws kan ti chon nge kan ti chon there are many laws in physics isn't it Newton for example Newton 3 laws of motion are the basis of the development of mechanics so you don't want about motion so you don't want Newton 3 laws ka poi mo me chu this law can successfully explain the motion of object in daily life and even celestial bodies such as planets stars etc in a physical phenomenon governed by various type of forces some physical quantity change hey physics till talk light kan so don't change. A time will change, and velocity will change. Mass change and mass to change low. If a body is moving in classical mechanics, and it's not relativity ani chu anilovin mo eng tlu ko chaka thok ni lovin ta chun an mass change lem lo ta tiang kha ka tiang change lo ma change so ma chu tiang che chuan physical quantities kan ti ba ka khan laws ten kha change so ma ten kha change lo ma chu tiang laws change vengai lo such quantities which do not change are said to be conserved and ni chu change vengai lo chu in order to offer suitable explanation shafia thiam tur chuan motion chungchang sir tur chuan thil pathum conservation pathum danglam ngai reng lo universe danglam ngai lo pathumom chung ta chu conservation laws antia, namely number 1 chun laws of linear momentum, laws of energy and angular momentum ting hi an lo duang chok ta ni chu heng ba ka hian conservation laws kan ti nature of physical laws anti te are many, like laws of conservation of charge quantity, and also law of conservation of spin quantity, law of conservation of lepton number te, law of conservation of baryon number te, law of conservation of parity te, alatam many. But only 3 things we're going to learn for today and for class 11. Amiga hian pathum hi kan enang. Number 1 will be the law of conservation of linear momentum. Okay, linear momentum. It states that if no external force acts on the system, the linear momentum of the system remain constant. Tiene chu linear momentum hey ngil linear chu ngil zong in thil kal chuan. For example ta hian example pali kaloda, when 2 billiard balls strike against each other, they move after the collision. Obey the law of conservation of linear momentum. Billiard balls te mo thil ball te pon yang chu atele lian te an in sut pop hian ti chuan in khoi zo nge atira an momentum an mani momentum chu dang ma sela an mal chuan e apum puyala khom chuan a momentum kha change lo ni chu the momentum of the system do not change kanti mass of the arizok no ma arizok le a velocity of arizok mo the heavier body may change, and the mass of the smaller body ball te zok rizong le a velocity to change may thai masala apum pui a total kanan belcom chuan will not change chu tiang chu conserve kan titani chu will not change tin hei kan thia tur chu enga tinge patele palian deu an velocity point ang ve pon san in suta pate chu alen glop zel zok kan ti chuan in order to conserve linear momentum money chu kan ti pon lo a pate zo khan len po du chong lo kluk tup po du big lo ma sela an in sut khan a te zo a hev a zang zok na chu an leng lo a velocity will increase ni chu an velocity kha tira inang ve ma se, but the velocity after collision will be increased nothing because in order to conserve the linear momentum. And next is law of conservation of energy. It states that energy can neither be created nor destroyed. However, it may change from one form to another. Til rang universe mi hi ni tang energy kan muwa te chuan hei kan lo eya kan lo liana thlai te pon an eya kan chu thlai te a chaknan ringa chu kan lo ei vele chonga ti khan ke ni pon na tho nan kan han mang le a koala ten ni po chon khoi trengeng en mu ti khan mu na dang nuclear fuel anti hydrogen atangte ka fusion hong in reaction men mu vele a khating zel khan a kiam theilowa aral theilowa tina ne chu amaro chu thil sang a form sang angin sound ani chun sound energy kan ti light ani chun light energy or electrical energy te kan ti dikhan sang in change mai ni he to soi ngai lovin kan thei me. So you just look this example of law of conservation of energy from daily life, and also you can add from these 3 points. Okay, karon sei to lo mayang hunare lo nan. So you look this 1 2 3 points, and you can also add some examples of law of conservation of energy from daily life. You can also refer to your textbook. The third and the last law of conservation of angular momentum. It states that if no external torque acts on a system, then the total angular momentum of the system always remain constant. Momentum kan tiju nichinghang kasala soilowa. It is the product of mass and velocity. mv kan ti khania and p tin annotation anti thina. Helai chon angular momentum anti vethungta. Angular momentum chu is the product of moment of inertia into angular velocity ni thung angular velocity le moment of inertia puntir ni chu thil avir kolin antinan shui mora lungthung la vai kol vak la ti chuan momentum na yanga masa akwala wangin angular momentum angle po nei dona amaro chu motor tlan ve thung chu ball lirte machine tlan ta chun linear momentum tlan kola ni lo chuan chu akwal ni chumo angular kan tina chan chu ti chuan in angular momentum conserve sela example tan enga tinge gan planet te when a planet moves around the sun in an elliptical orbit its velocity increases when it is close to the sun and decreases when it is far away from the sun in shato ngayam planet rang hin ni a solin ni an health in elliptical orbit and dia ni an nai hian an clock chaksat zela ni an lathian clock mong thina ni kha mishing siam chope mon dilwa pathian ina omzenei taka alo plan ani chu enge kan ti chuan physics atang kan an zir chianga e universe hian because they try to conserve the angular momentum tika kan mu chuak chak zo khania kan an siam chuak ni lawin a omani tika chu enge mingatan conservation of angular momentum anti chu ni tani. So when the planet moves around the sun in an elliptical orbit, its velocity increases when it's close to the sun and decreases when it's far away from the sun because it happened as a consequence of the law of conservation of angular momentum anitani. Angular momentum conserve an du wang khan khwanu rel danang khan an mani khan nin nain lo thlok chak ve top me ti to mayang kan thriat thiam dan turin nin lat khan an thlok mong ve ringot mai ni chu tiang zel chuan an mani chu poni lo a hei tornado kan ti te chuan chu baka chuan from the springboard a diver an virdan hei mi tes in twin leusia ka tamo leusia kherlo wa ta po tian tui cheng thiam chuan lungpui chunga han dinga an bin thiam rio angular momentum conservation kha thiam body na lo man thiam to rio chuan an vir thiam thina ni. So you have to look all these examples, okay? So you have to answer the following questions from this topic. Heng o equation karanda choka textbook a pokhanin huthein karinga chuan khatinga textbook a lo makha you have to read the textbook and try to answer the following question: what is the field particles of gravitational force? By how much is nuclear force stronger than electromagnetic force? What is nuclear force? What is the field particle in weak nuclear force? Tita and state the laws of conservation of linear momentum, energy and angular momentum. Mention one example of the application of each law from daily life. So that will be the topic for today.